Welcome back to the GoEngineer YouTube channel. I'm Robert Warren. In today's video, we will look at the differences between SOLIDWORKS Simulation Premium and ABAQUS. Before we get started, make sure to hit the subscribe button if you haven't already. Every tradesman, whether a carpenter, electrician, plumber, all have a set of tools specific for the job at hand. As engineers, we have our own tools that we use. One of those tools that should be available to every engineer is finite element analysis. Finite element analysis, or FEA for short, is a virtual testing software that allows engineers and designers to test their concepts virtually. FEA is best used during the design process, reducing time to market with more design insight, fewer prototypes, and optimized designs. Analysis is a tool in the engineer's toolbox. You probably recognize this tool on the screen. Everyone in America has one of these in their drawer. It's a flathead screwdriver. It is designed for one purpose: fastening or unfastening flathead screws. But if we are all honest, we use this for much more: a chisel, scraper, pry bar, a punch, and many others. This flathead screwdriver is like SOLIDWORKS Simulation. It has a specific purpose as a tool, but it can also be used for other tasks, while not always designed for them. That is where these other bit types come into play. These bits are specific for given fastener types, and they do these tasks perfectly. ABAQUS is a program that offers these additional bits, the next level of tools to take your designs further. SOLIDWORKS Simulation has a good deal to offer, and for most engineers this is a robust, comprehensive tool. But there are cases, high strain, fast dynamics, nonlinear buckling, to name a few, that require more advanced tools. This is where ABAQUS adds to the toolbox. ABAQUS provides powerful tools to solve these more complex engineering problems. This is but a few of the additional bits, if we stick to our screwdriver analogy, that ABAQUS offers an engineer. And in this presentation, I want to focus on 9 key tools you can add to your toolbox to solve your problems more accurately, faster, and realistically. ABAQUS offers best-in-class contacts. Contacts describe how parts and assemblies interact with each other in the virtual environment. The general contact aids in setup time and is the most robust, no-penetration contact offered in any FEA tool. Advanced connectors allow virtual pins, bolts, including threads, welds, etc. to be analyzed and tested for failure. Multi-step capabilities allow preloads to be applied properly and in order. Advanced meshing, including hex elements, for high-strain applications, material calibration, and an explicit dynamic solver allowing the engineer to tackle the most realistic of problems. Let's look at a few examples. What you are seeing here is a pre-tension step on the bolts. There's a spring connector representing the gasket in between the flanges. The flanges are stressed due to the bolts being tightened, before adding a second step of the internal pressure. In the last example, we used advanced connectors, advanced contacts, and the multi-step loading. The next example is this roller bearing. Normally in SOLIDWORKS you would have to do all the contacts manually, meaning each one of the rollers would be paired with the inner race. Each one of the rollers individually would be paired with the outer race. This generates a lot of manual contacts and a lot of time to set up the model. Using the general contact option in ABAQUS does it in just a few clicks. So all the interaction of the rollers and the bearing races are done quickly using the general contact tool. Another thing to note is this type of simulation would not be able to be solved in SOLIDWORKS Simulation Premium. The general contact is allowing for not only all of the contacts to be taken into consideration, but the rollers to roll and move in a 360-degree movement, that large displacement nonlinear application. The other thing that ABAQUS is allowing for is that downward load. That's why you see stress starting on those lower rollers, and then it dissipates as the bearing rotates up through its full 360 degrees. So again, this was a great example of a general contact, advanced contact capabilities, and advanced connectors. This side impact simulation is a great example of a nonlinear, explicit dynamic study. Not only is it fast with respect to time, but it has nonlinearities and nonlinear buckling. Fluid cavities, a fancy way of increasing surface pressure of an enclosed volume, were used to inflate the airbag. The nonlinear buckling of the A pillar and B pillar are captured perfectly. The dynamic response to the dummy, seats, and interior are also captured appropriately with respect to this impact. This is a highly nonlinear problem and just could not be solved in SOLIDWORKS Simulation Premium. One of the advanced capabilities of ABAQUS is the ability to offload the simulation to the cloud. We can make use of up to 192 cores of cloud compute to solve this analysis. It solves it faster and gets you results quicker, so you can make better design decisions. In the last example, the nonlinear explicit dynamic solver was the biggest showcase. That problem could not be solved without this solver. Cloud computing made it faster to run, multi-step application of the airbag and the crash, and the nonlinear application. Let's take a look at a few more examples with respect to ABAQUS. In the upper left-hand corner, you have the crimping motion of this metal connector in and around the wires. The general contact is showcased here, allowing each individual strand to move and come in contact with everything else with one simple setup. We're also seeing high plasticity in the metal forming in and around the wires. We have a crash test simulation of this buggy exterior frame, and we can see that nonlinear impact into that stationary object. The next over on the top is a rubber gasket for a window, or let's say a refrigerator. What we're seeing here is a couple things. We're seeing an incredibly high strain application. So that is where a hex element comes into play. That's something that you just cannot do with a tetrahedral element inside a SOLIDWORKS Simulation Premium. That high strain application and the nonlinearity of the material is allowing for that crush to occur. An impact on a roll cage chassis from the side in the upper right hand corner. In the bottom left hand corner is probably the most important aspect on this screen, however it is the least eye catching. This is our material calibration tool, and what it does is it allows you to bring in experimental data, raw data for stress strain curves, stress stretch curves, simple tension, biaxial tension, planar tension, and load those into the material calibration tool. What that does is it's going to pick from a laundry list of mathematical models for materials and make sure that you have your best fit. What you see there, the black is the experimental data. The red is the material calibration tool going through multiple different materials and finding the one that has the highest match. That way you know you're using the right material and the right material mathematical model for your type of study. In the center at the bottom is an example of fracture or mesh deletion. So you have a bullet entering a ballistics gel. Not only is it expanding that gel, but it's ripping it. It's causing fracture, and that can be done with the advanced element capabilities. Right above it, you see a series of bottles inside of a cardboard box that is being dropped. So not only do you have the bottles loosely packed inside that box, there's fluid inside the bottles as well, and that cardboard has certain criteria where it can come open depending upon the drop. So this is a very realistic simulation of dropping this, something again that we just cannot do inside a Simulation Premium. On the right in the middle is a bottle crush. That bottle again has those SPH, those fluid elements in it. So you can see as that comes down, the water is incompressible. It forces the bottle out from being buckled linearly straight down or non-linearly straight down. And then the fluid actually spills out of the bottle as it continues to be crushed. Then the last example is preloading the shrink wrap around a pallet full of boxes. And then the next load is running that into a wall for a dynamic test. You can also see the fracture element here where that shrink wrap is actually ripping due to the strain being too high in that simulation. So again, another set of examples that kind of showcase where ABAQUS really shines those more realistic, nonlinear, dynamic type applications. To recap, SOLIDWORKS Simulation is a tool in the engineer's toolbox. It handles the majority of problems that an engineer may see, but there are times where you need more realistic, faster results and more accurate results. That's where the Simulia brand of products, and specifically ABAQUS, comes into play. Is that next set of bits for your screwdriver set. It's that next set of socket heads for your socket set. It's the additional set of tools that you need as an engineer to accurately depict your problems. Thanks for watching. If you enjoyed this video, please subscribe and leave us a comment below if you have a topic you'd like us to cover in a future video. Visit our website, goengineer.com, for access to professional training, upcoming events, and more from your #1 online technical resource. This is Robert Warren. Bye for now.